Hi guys, welcome to a new series of videos. So we just finished a long running formattables refactor. I mean, this is really long running. I mean, people that you may think it was only the 20 odd videos that we created, but in reality this refactor was much older than that. It's been a target for many sprints. The refactor we just completed. If I just have a quick look at one of our charts, you see here the formattables cleanup. That has been part of our roadmap probably for as long as I can remember, in various guises such as generation model cleanup and so on. So we achieved that now, and we still have a few hours to go on this sprint, so this is turning out to be a good sprint. So I thought I'd start a new series of videos now, which is well, the second bit of the work. I guess it probably would fall under the physical model cleanup, somewhere in between, I guess, because it's more to do with the text model, so I guess we probably should have something there. Because the real physical model cleanup is going to be when we replace the hacks that we've done on the back of the formattables cleanup. That's really the actual physical model work. So what is the objective of this work then? So we started it already before this video. The idea is that we had created this fake separation between the text models. The idea of the text model is that each text model is dedicated to a particular technical space. So for example, the C# model is dedicated to the C# technical space. Well, that's the major technical space. There are also minor technical spaces inside of it, such as, for example, the Visual Studio project files. And similarly, the C++ technical space is represented by the text.c++ model. And the idea was that we wanted to, because we didn't think there was enough commonalities to justify these things being bundled together, and because these models were quite gigantic in the past, they had all of formattables and fabric and all sorts of other mismodeling things that we did there, mismodeled things. They existed in isolation. But with the grand unification that took place with the logical physical space, it became clear that the technical spaces are really just a bundle of text transforms, and they don't really justify existence on their own, by their own, really. So what we really want is a excuse me, a unified text model, and excuse me, a bit of water, I think. Excuse me. The unified text model should contain all the different technical spaces. Now, I guess you probably will say that this model will become quite large in the future, and that is a valid point. But we will just do that on this, well, with this refactoring, I think, because at the moment it doesn't seem like there's a justification for having separate models. And there is a lot to gain by having a single model, because we want all of these text transforms to obey common interfaces. In the past they didn't, but the reason why they didn't was because of the modeling errors. It's because each model had each technical space had their own formattables model, and the formattables were sort of an adaptation of the logical model towards the specific physical space. Well, technical space, I mean. So what we started then is we started to move things around, and the first problem we identified quite quickly was that in order to move the transforms, we need to move the helpers first. So as you can imagine, the helpers are always a pain in the backside. So we started doing some work on this before we started recording, and what did we do? We concluded that, well, if we came up with a common interface for all the helpers, which is simple enough, I guess. But the problem is there was sort of an implementation error whereby the helpers were relying on the assistant, and the assistant is relying on helpers. I've mentioned many times in this series of videos that cycles are kind of the worst enemy of coding, because what cycles do is they don't allow you to test anything in isolation. I mean, the assistant is already in itself a nightmare, because as the name already implies, assistant is a terrible name. It means we don't really know what the job of the assistant is. So it's just a bundle of things. But to make things worse is the assistant is going through all the helper transforms, and the helper transforms are using the assistant in order to determine what's enabled and what's not. So the first job is to try to break this cycle so that the helpers don't rely on the assistant, and to be honest there is no good reason for that anyway. It was just laziness. And once we've got that, we can then start to make all of the helpers use this common interface, which is actually going to be a base class now, an ABC. And then we can register against this repository here, which, to be fair, yeah, is correct, it's manually generated. And at which point, hopefully, we can start to lift all the helpers over to this. Well, I'm not entirely sure if that's the best thing to do, but we could probably create at least some kind of helper top level transform, which is already there, the helper chain. And then instead of using the assistant, we can just call the helper chain, and the helper chain will then go and do its thing. So the text transforms will call the helper chain. The helper chain will have access to the model, at least a physical. So here I think we may need a physical meta model, because we will have to somehow determine enablements. And there we are, it's done here. So we need the physical model, sorry, which means right. So I don't think we finished all the analysis in this. Now that I think about it, let's make sure that we are, yeah, we are clocking. So let me just explain the problem. In order to determine enablements, in order to determine what's enabled and what's not enabled, we need access to the instances of the physical meta model. And those instances at the moment, for better or worse, are captured in the meta model properties. I mean, we've already mentioned quite a few times why this is not exactly ideal, but this is going to require quite a lot of work in order to sort out. So for now, that's what we've got. So that basically means that in order to have the meta model properties, which is in effect just the variability applied to the meta model in the physical space, we need access to the physical model. Now, by default, as things stand, the physical model does exist in the logical physical space, of course, but it's not something we tend to supply to text transforms. We tend to just say to a text transform, here's the element, and is the logical element, is the physical element, go away and transform yourself. Which then means that we won't be able to call this alpha transform from within a text transform. So perhaps that is a solution, in fact. Perhaps we should not call it from within the text transform, but instead call it from without. So what are we saying then? We're saying, let me just grab a notebook. At present, we just have to understand the differences between the new world and the whole old world here, and try to do a bit of a sort of logical consequences of things. So in the new world, we have a text transform, and the model to text transform, and the model to text transform at present is taking the logical representation, a logical element, and the physical element, and a context of some kind, which is not relevant for this. Now, we don't want to supply the physical model as part of the context, because it's just a conceptual thing. A context basically is a sort of the background in which a transform executes, and to supply a model as a context implies that that model is very static. So the type of models we think is acceptable to be supplied as a model are things like a physical meta model. So the physical meta model is suitable, as is a feature model, because these are things that are sort of static to an extent. Once they're constructed, they're valid for any model that you may execute, unless you reveal the code generator. So that's kind of like a context. or a tracer or so on. The mapping set repository is a bit more. Don't think that is actually suitable as a context, but there you are. As a context, the memory of context. However, the physical model is not something as suitable as a context, because the physical model is actually the thing we're generating, because you have to remember even the meta model instance part of the physical model is still something that's dependent on the current model. So if we start putting those things in a context, it becomes quite hazy at what's the context and what's the target of a transform, because it's sort of, we don't really want that confusion really. At the moment it's quite clear in our minds what's one thing and what's the other. So that doesn't seem like a good thing. So then we have two options. We can either change the interface to all the text transforms such that they take the physical model, which is something we could do. I mean, at the moment, in fact, to be honest, it seems like that's where we're leading towards. Now, in fact, it's not quite what we're saying here, because we're saying that we only apply if it's enabled. So somebody outside of us is doing that. So presumably, if I look at the model's text transform, we haven't quite worked on that yet, so it's not been updated. But so we have two options effectively in terms of design. We could either say that the model text transform has to have a copy of the physical model, and it's not part of the context, or we could say that the top level transform that runs all the text transforms has to run the chain first for the helpers, and then can supply as a parameter the helper content into the apply method of the text transform. Now that would make a bit more sense, because this guy here will have access to the logical physical space, as you can see here. There it is, the logical physical space. So the chain itself has access to the logical physical space, and it could potentially supply it. However, as you can imagine, this will be a very, very big breaking change, and we just need to unpick the work so that we don't end up again in a massive refactor that requires changing everything all at once. But we always like things that can be changed one step at a time. So however we do this, we need somehow to have this in a step-by-step, slow incremental change. So that's not going to work. So then plan B then is to change. The key question we're asking here is, how do we get access to the physical model, really? That's the key question. Now, perhaps what we can do is to say, as a hack, we can supply the physical model in the context, sort of a step one. Now this is not really ideal, as I mentioned, but let's say we do. Then if we do that, then when we create the helper chain, we could easily supply the physical model there, because we got it from the context. And so that means that all the transforms can do that quite easily. And then once that's in, then we could then, if we want to, we can then move it up one level, because then that gives us enough leverage to move the helpers here. And then once all the helpers are in the right position, we can then move all the formatters or the model text transforms, and then everything is in the right model. And once everything is in the right model, we can then say, okay, now let's change the interface, and we want the interface to then be supply us with the contents of the helpers, because remember, the helpers are in effect something temporary until we get to the PDMs. So we don't really want to spend too much time on the helpers, really. So I think that's the right solution to do. Again, it's not brilliant, but these are all engineering trade-offs. So none of this is going to be brilliant, I'm afraid. Now let's double check we are recording. There we are, 14 minutes. Okay, cool. So okay, so that seems vaguely sensible. What I'm going to do is just to make everything consistent. Let's just then do a couple of changes here. First, let's make sure that we understand. Okay, I can hear some funny noises. Just bear with me a second, please. Okay, that's sorted. So the first thing is we need to understand the context can't be automatically generated purely because interestingly enough, this context is also not being automatically generated. Let's see how many contexts we have that are actually being generated. Oh no, they are being generated. Sorry, apologies. Typable means that it only generates the type side of it. So that's all right. So we've made a mistake and now change here. This is actually co-generated. Let's keep the color correctly. And there's nothing stopping us from supplying the physical model to the context and still getting it generated, I suspect. So I think that's going to be identical to this. Something like now, as I say, this is very unelegant. I apologize in advance for this big hack, but the other problem we have with this as well, actually, which is an even bigger problem, is that at present that context is being generated in the orchestration model. So if I have a quick look at the factory, so if I say something like context factory perhaps, getting some weird errors from Tremax at present for some reason. I wonder if it needs a refresh. Okay, perhaps this would solve Tremax's issues. So as you can see here, we are creating all the contexts purely because we have this notion of a context of all contexts in orchestration. It may not be the cleverest of things, but that's what we have at present. And that contains the logical physical context as well, which is called the text context at present. Now I think that is a problem because there is no easy way of saying, yes, as you can see here, this is just a plain POCO, a real object, not a pointer. So I'd have to make a massive copy of the object or now start using pointers, otherwise we're going to end up copying across the physical model, and also the factory is not really designed to initialize, as it should be really, to initialize the context. Because the factory, of course, is the initialization of the context is happening very early on, as you'd expect, in the chain, and then the context, like I say, is supposed to be something really contextual, rather than something that is actually part of the process. So this is not a good idea, really. I mean, all my instincts were telling me this is not a good idea, but now I think it's even less of a good idea. So we need to figure out how to supply this bit of information to the helpers. This is really quite the key of the process, really. But there is one thing we're not taking into account at present, which is, I'm not sure how, but the assistant, I'm pretty sure the assistant, let's have a look at an assistant. The assistant must have access to the physical model somehow. So let's have a look at what the assistant is doing. So it's got an element, it's got a context. I know why. It's because this context is a C++ context, and I believe this is where things start to get interesting. Yes, so this context, so as you can see here, this is a bit of a dodgy context. This context is in effect containing a full-blown logical physical model, and hence why this is handcrafted. This is probably a reference to a model as well. So the reason why this is the case, so this would allow us to survive for now, of course. We could easily say, oh yeah, look, the physical model is available in the logical physical model. Grab that, supply that to the helper, and everyone's happy. And that would enable us to move to the next stage. But then the problem will be that at some point there will be no C++ context, and this context has to be merged with this context. At that point, then we have to ask the question, how are we going to get the model into the context? And does it even make sense to have the model into the context? And the answer to that question is, well, no, not really. It doesn't make a lot of sense. So it's really the fundamental question we're asking from the beginning is, how are the model text transforms accessing the physical model? That is really the question. At present, we have this hack, but that hack is not really the final destination. So we need to replace the hack with something slightly more sensible. So really the right solution for this, which is a very painful solution, is to change the interface for the text transforms to take the physical model as part of their apply method. So you should have a context, you should have a logical element, a physical element, and the physical model. And then it should supply that physical model to the helper. And if we do that, in theory, we should also notice right now that the assistant, so if I then go back to the assistant.cpp and I look for uses of context.model, hopefully we, interesting enough, we are also using the logical model. So let's have a look at all the uses we have here. So we have the logical model, we have the physical model for the meta model properties. Yeah, okay, so this is quite expected really. So what we're saying at the moment is this: we need the meta model properties, as you'd expect, but we also need the streaming properties, which are a logical property. We shouldn't really grab the entirety of the physical model for this. Now, I don't want this to be a context like I explained, because this is dependent on the current model we're processing, whereas the context for me is something that's going to be immutable for the whole transformation. So it has to be something else. They could be supplied by reference. Maybe we just need two different properties being supplied really. I mean, the other thing as well, of course, is the streaming properties are just being supplied at present purely because we have not done the right job, and the right job is to supply these as part of the attributes themselves. This is a refactoring that needs to take place, but we just don't have the, we're not going to get involved with that right now. So these are two hacks, I guess, that we need to do in order to move forwards. And we just need to figure out what's the best way to do this really. So we should really remove these from the context, supply them to the transforms, these two parameters, and then or of course alternatively we could create two different kinds of contexts. I mean, this, I don't know which one is worse really. We could create a temporary context that is like a local context like this. So there's the notion of a global context and a local context. The global context can stay as it is, and we can have a local context that just has an assorted set of properties, and then we can initialize that context and then supply that to all the transforms. In fact, that might even be the solution to this problem. Because at the end of the day, the two things that are going to go in the local context are just two temporary things that we need in order to continue with our refactor, and at some point they're going to be removed. So we can afford to create a type that's purely a temporary type, just to breach the change that we're trying to make, so that we don't get too stuck. If we did that, the only slight annoyance is that whilst we're doing this refactor, we're going to end up with the local context containing, well, we need both the local context and the other local context. which is this guy here, for a few commits, quite a few commits really, until we get everything moved across. Or we could, and that might be the solution, get rid of this context altogether and make that the local context by simply supplying the helpers and the tracer plus the other properties in that context. Okay, so that's the right solution really. So we already have a context being supplied in the transforms. So if we were to just move that context over to text, call it local context for example, make it fit this, then get everybody to point to that context, and then slowly refactor that context to just have the properties that we need, and then eventually that context will then fit what we require for the helpers interface. But of course can't do that until the helpers interface is available, because of course we are using the helper transform and the helper transform at present. So as you see, we've just done a loop in the entire refactoring. The purpose of the current exercise is to move this guy here over to here, but in order to move it we are saying that we need to have a type here that has a dependency on it. So this is now a loop, it's a cycle, and the refactor itself is a cycle, and that means we can't do it. It's a very tricky thing really, it's just a question of ordering things. We can't move the text transforms because they depend on the helpers, and we can't have the helpers depending on text.cpp. So that's why we started by trying to move the helpers themselves. But in order to move the helpers we need some kind of way to supply all the inputs to the helpers. And that's where it's a bit tricky. I mean, perhaps we should just try to do a big, massive hack. We could, for example, have some static state available to the helpers. Set that static state. I mean, really, really big hack. Because at the end of the day, it's just temporary, right? So let's imagine that the helper chain has, I don't know, say a pointer to a physical model. A static pointer to a physical model. Now this is very, very dodgy, but if you humor me for a second. And then we could supply that by whatever means. That could initially just be supplied by this guy here, by taking a reference of the physical model of the context, since it's already there. And then eventually, as we move upwards, we can then say, actually, that is then supplied by this guy here, for example. And that would give us a breathing space, I think, to actually continue with the refactor. I think that's going to be the solution. This is a very, very nasty hack, but it's just, I mean, many things are temporary, but this is really, really temporary. We just need to we just need a way of breaking up the cycle here of the refactor. Otherwise, we're never going to be able to move. So I think that's the right solution, really. Just not very nice, but if the helper chain has the static state, then it will be quite easy for us to just set that static state whenever we got access to the physical model, then run the helper chain within the model to text transforms, and then in the future we can slowly start refactoring that static state into something slightly more sensible. But at least that way we can move all the helpers and all the text transforms to here, and then we can worry about that. So okay, so that's what we're going to do. Very, very big hack. Right, so let's see, what do we need to do that big hack then? For starters, we need to figure out where we are in all of this. So we started doing some work here in text. So the helper chain, I don't think it's been worked on at all. No. So we have this helper chain here, and we also have the assistant, which I think does the get helpers at present, which takes the helper properties, retrieves all the helpers, and then in here as you can see here, checks to see if the helper is enabled. Right, so this is in effect the guts of the chain. And if we look at what we think the interface of the chain should be, we have a stream, although I'm kind of thinking whether we should just return the string. I mean, we are doing a lot of nastiness here, but I think nothing stops us from just basically saying just return as a string. I don't care how you got this, I don't particularly care. But so you should take a physical model. Well, as we said, this now becomes something a bit more sinister, something more like a physical model, class scope, public perhaps. I mean, this is a pointer, of course, but can't really represent that at present. Then the thing we're trying to do, then the artifact. I'm not entirely sure we even need the artifact, if I'm honest. In fact, to be honest, we don't even need the... Yeah, as you can see here, we don't even use the element either. So we just need the element ID, because the element ID then enables us to obtain... okay, no, sorry, we do, because we are going to the helper properties of the elements. And then we loop through the helper properties, get the helpers, and then get the helpers to do their thing, and then we're done. So this is going to return a string. So we don't need a physical element, but we do need a logical element. And you probably could go as far as saying you don't need a logical element, you just need the helper descriptors, which probably would be correct. But it would be nice to be able to say which helper or which element we're doing, so something like that, right? So as you can see here, what do? We have a physical model, which we remember. We have a registrar that keeps track of all the helpers. We have an apply method that takes an element and then returns a string. And with this, we have the basic machinery to be able to regenerate all the helper infrastructure. We just need to implement the registrar, the repository, the helper transform, and the helper chain. Okay, so we are 30 minutes into this. So let's try to time box this video then. So our objective here will probably be to try to implement these classes here. We're not going to get very far, but if we could implement the interface, the chain calling the interface and copying the code from the assistant, the basics of the registrar, which is copying and pasting from the existing registrar, and then the repository, of course, which is typable. I'm not quite sure why we made the repository typable, because we could have generated it, I think. The same way we generated the context, I think. I'm not entirely sure. I think we could probably use the code generator a bit more here. Let's just have a quick look at how the I/O for the helper transform looks like. Yeah, and it's fine. So there's nothing wrong with this. So okay. So what I'd say is let's just try to make things a bit easier for ourselves. Let's just not bother generating by hand the repository. Given that there's nothing particularly special about it. We do need to render it manually there. Oh, and also we are using the wrong colors here, which is confusing me as well. So if we could just change these guys. to slightly lighter color of blue. So we use the darker blue for things that are header only interfaces basically. And the second thing we probably want to do as well is we want to say, well, if the I/O pretty printing is trivial, then please just co-generate it for us, because I mean we're not going to add very much by doing this by hand. So, right. So this looks more like the shape of the things that we want to do. So let's see what the co-generator says about it. Let's show you what the co-generator is saying. So it doesn't seem to moan too much. Let's try to compile it whilst we look at what got generated. So basic I/O as we'd expect, not a lot of changes in the rest, so I think this would be fine. So we don't really have to manually craft those guys. I mean, just made our life easier slightly because we now don't have to worry about the repository or the context, so that's good. We also don't have to worry about the helpers, the I/O of the helpers, which is trivial, it just writes a type name, so that also should be fine. Although, having said that, that's an interface, so I wonder what that means. I think this might cause problems. Let's have a quick look at the I/O for the helper transform. It just dumps to the stream. Seems very, very straightforward. Still having problems with Tremax again. Strange, Tremax just seems to occasionally start moaning. Every time we open up a new file, in fact. Seems to be the main reason. As you can see, we just opened up a new file got generated just now, and Tremax seems to then get a little bit upset. Not entirely sure why, but we don't really need this file, so let's just close it. Right, okay, cool. So, where are we then? Slightly losing focus a bit. So let's just start from the helper transform then. We need to start somewhere, and the helper transform looks as good as any, so let's see what the helper transform looks like. It's going to be very similar to the existing helpers. In fact, we've already started implementing it. So as you can see here, we have a physical model for is enabled. So that's where we're going to make our changes now. So I don't really like the notion that we are supplying the stream. I think it's better if we just return the stream. Supply an element. We don't really need the artifacts. And we shall need the, well, to be honest, I don't think we need the helper properties and the element either, so let's just go with the element. Just out of curiosity, is enabled. Right, I think for is enabled we do need the artifact, funnily enough. Because is enabled, well, it doesn't look like it from here, but we will probably have to dispatch this. Right, so this is where I need to think a little bit. So let's just look at templates and look at examples of is enabled. Oh, actually, is enabled is probably here only going to refer back to the assistant. And now we have to go back to the assistant and see what the assistant does when I call is enabled. So it doesn't look like we're depending on a particular position in physical space specifically. So if we are in the types class implementation, okay, we are relying on a physical metaname ID, so we do need some kind of way of knowing where we are in physical space. So in order to determine enablement, we need to know where we are in physical space, which makes sense, otherwise how would you know what is enabled, right? So if I just look at transform itself. We just need to figure out how we're going to have access to the physical position of the elements. Seems a bit heavy-handed to request all of this, really. I mean, we need that because we need to figure out where the enablement is. We need that mainly for logging purposes. That's telling us where we are in space. That's also present in the elements, so we definitely don't need those. Now, that's probably enough, I think. Let's just go with that. That should get us going anyway. We have operator. Oh, actually, one thing we should be doing by now is committing the code generator changes. So text generate repository. Well, do not handcraft repository, I guess. Right, so that's out of the way. And then, now that we're here, we have this kind of abstract base class of ours. And we just need to start implementing it. So I think the only thing relevant here is really this method. We have this equals operator that I'm not too sure what we're using it for, if I'm honest. So let's start by seeing what happens if we remove it. So we started implementing string enabled. We also have the equals operator here. Just want to see if we are really using it or not. We are. Right, okay, we just need it because we are part of the repository, and then the repository will get upset if we don't supply equals operator. I mean, this is very bad, but that's what it is. So let's just go with that for now. And so it seems like we've implemented basic version of streaming enabled. Now, as I say, I want to make this a bit easier and remove that guy from here. Hopefully not too much should break. Then all we need to do is we need to do something like const outer by reference hp e dot helper properties, and then hopefully okay, so the problem here is that we have many helper properties. Right, okay, I get it. This is not right, actually. So the problem is, of course, the element has helper properties for everybody. So we can't actually do this. So we need the specific helper properties for the current helper that we're trying to work on. So that also means that we made a mistake here. So let's see what we changed. Right, so as you can see here, we're supplying a specific helper as well as in there. So I think I'm just going to revert everything we got here. Right, let's just go back to where we were. So there is obviously a reason for things the way they were. And that is that we need the specific helper properties that we're working on. I think that would do. It's taking a while to get our brain into this. Right, okay, cool, fine. So clearly this should compile because we haven't done any changes now. So we'll leave that running. Now then, if we have the helper transform, we should in theory, be able to implement the chain now. And the chain is going to look very much like a normal chain, I think. Let's just grab something from the main chain. Well, it's going to have some commonalities, presumably. So we're going to need... well, we don't need a context, actually. In fact, I wonder if it is going to have a lot of commonalities, really. Well, we need a context because we need a way to trace, which we entirely forgot here. But I suspect if that's all we need, we could just give ourselves a tracer. Actually, I wonder what the helpers are currently doing in terms of tracing. So if we just jump over to a template and take, just observe, in fact let's just use Dogen org model representation, and let's go to a namespace such as say types, perhaps. Yeah, types is a good one. And in types there should be a smart pointer helper. There it is. What does this guy do then? Yeah, there is no context. There is no tracing. So let's just follow this pattern, because I mean, let's just not change things for the sake of changing. This is all temporary, so we don't really need that. So the chain then requires the element. I presume we're also going to need the artifact. The physical element. Then presumably it will be our job to look through the different entries in that artifact. So let's just go with that for now. So really what we really need is, more than anything else, is this guy here with something like these two chaps, and then these two chaps here. Oh, actually one thing that I did want to change, I wanted this guy to yeah, again, we probably are making changes for the sake of changing. We have to concentrate on not breaking too much. So that would be nice to do that, but it's going to waste time. So let's say we have an apply that's roughly like this. We're in Portuguese. So our apply is going to be roughly like this. I must say I'm slightly mentally exhausted at present, so it's going quite slowly. Right, so what is this then? The apply is basically saying, give me a stream, give me the element you want to work on, and the artifact, and I'm just going to go through all of them and do whatever it needs doing. And because the helper chain has got access to a registrar, okay, now we're going to start having some problems. So the first question is, what does the registrar do? And I think it doesn't do anything. Indeed it doesn't. So let's have a look at a real registrar. This chap here. So it's gonna have the repository. I think we already have a reference to the repository. We'll probably need a reference to the transform itself, because we are the registrar. So of course not the CPP one, but the other one. And then I think we're just gonna copy some of these things. So no, some kind of validate methods, whatever that does. the validate method is this guy there, and then some kind of way of registering transforms. We don't really care about transforms themselves, but we do care about the helpers. And then, right, so this repository is returning all of the helper formatters. I suspect that's just another way of saying it's returning the repository. So we could just basically say something like consts. Well, we don't really need to say all of this because we are inside of transforms. And we could say something like this. Please return me the repository. That's just a const method. And that now looks vaguely like a repository, I think. Provided that the repository is in... Must use class tag to refer to repository. Ah, okay, right. It probably means that we just abuse the name repository a bit too much here. So I'm just going to name this helper repository just for a laugh. Now we don't need a swap. Right, so something like this, right? Very, very simple registrar. So what do we do then? We check to make sure this is vaguely correct. We allow people to register helper transforms, and we return the contents of this thing once we finish with it. And we just have the repository in our state. So that seems simple enough. Now if I try to implement this guy, what we'll do is we'll just start from scratch here. Going to quickly clean things up. I'm sure there are easier ways to do this in Emacs, but sometimes one is just lazy. So here, very simply, we just return the repository, nothing particularly special. Now the validates, probably nothing particularly clever either, I don't think, but we are going to need some kind of logging. These are just basically some kind of very simple sanity checks. Oh, and if we have a registrar, we probably need some kind of associated registrar error. Sadly we can't copy and paste, but quite annoyingly. I mean, we can copy and paste, but they don't end up in the same namespace, which is really defeats the purpose, I guess. So we need some kind of dark purple for this, and this guy throws that guy. Okay, so let's just generate an exception. Oh, sorry, it seems like we've already generated that exception somewhere. Ah, there we are. Apologies. So let's just get rid of that. Okay, so all we need to do is to obtain the error. Notice that we just moved from the C++ to the C# registrar, but there you are. So text.transforms.registrar. Now I'm gonna skip a few of these errors for now. No, not all of them, because I think some of them we use for the helpers. And also I'm gonna, and not that I don't trust this C# helper, but we use it more in Angular and C++, and I think it's very much a copy and paste exercise anyway. So right, so now let's just start to implement these guys here. So the helper transform validation is this guy. Very simple. As you can see already, we found things that C# didn't do, or at least the comments are slightly different. Okay, and that seems to be enough to implement that guy. Let's just simplify this a little bit. Right, now then, we've done this already, and here are we going to do oh, that's most interesting. I thought that this guy would just be calling these other validates, so that doesn't seem to be the case. I know why. It's because we probably validate on registration, so that's fine. So the validate itself, what we're going to do is we're going to copy and paste this code, but we're not going to actually use it. We're going to say something like, so we're going to basically say if the repository dot helpers by family dot empty, and then we could say no helpers. So we don't really expect, this is just a very simple final sanity check. The idea is that if you do some kind of weird configuration error and you end up with no helpers at all, there's no point to proceeding. I mean, this is very bad, so we should just throw. And we don't really need the rests. And if the repository isn't invalid, we can just dump it. Repository, and now of course if we are dumping the repository, we need some kind of IO. That will be the IO, but from here. Okay, so the registrar is kind of coming together, just slowly, very slowly moving across things from over the existing technical space specific registrars. Now for the register method, we copied the wrong registration, so that's fine. Let's just get rid of that. What we really meant is register the helper transform. So we first validate it, then we don't really need all this rigmarole. We can just say repository, and then whatever repository has. So we obtain the helpers by family, and then we just slot it in on that family by the physical meta ID of the owning formatters. Now I think we may have done the right thing here already. So if I look for my helper transform interface. Hopefully we're already fixed now. We still are carrying around lists of strings. Right, fine. That's not a problem. I mean, ideally we should just have physical meta IDs there, but if we do that, I suspect we're gonna have to change all the helpers. Let's have a look at how they look like at present. So there's some kind of whale transform for this. So let's have a look at the whale transform then. It'll be around here somewhere. So C++ helper implementation, this guy perhaps. You can see here we are returning right, this implementation is rather dodgy. We are relying on traits, which is not really a good thing. Ideally we really want to return the owning formatters from the physical model, but in order to do that we would have to include the right factories, and that will be quite a non-trivial thing to do. And given that the helpers are actually something that we only need for now, what we probably will have to do at some point is we'll just have to hard code this, forget about traits and just hard code this to strings and just return the strings, and so that we can deprecate traits. But we're not going to touch this now. So it's fine, we just take a string, we convert that string into a real physical meta ID, and then we just push that, and that should be fine. So I think this kind of vaguely resembles an implementation of a registrar, though I think we may have broken something. So helper chain, where is my helper chain? Oh, there we go. We just forgot to. Okay, right, that's fine. So the problem, no, not the problem, but what we need to do now is to implement this slightly hacked version of the helper chain. So what this guy will do is we'll do a few things here. First thing it's going to do is to say it needs a lot of static state. One of it is legitimate, which is the repository. How are we doing for time actually? 12 o'clock, 1 hour. Right, so part of it is legitimate, so it needs a repository. Oh, actually, to be honest, not a repository, but a registrar. Yeah, that's correct. It needs a registrar. Now let's think about this. Who would own the registrar in the case of the technical space specific code? So that's probably going to be something like perhaps a model to text chain. Not quite. Maybe a workflow. There is no workflow here. Maybe this workflow. Yes, so the workflow contains the registrar here. So we just need to copy this logic. Notice this is public, and then we could just say something like we need a registrar. Okay, so we have a registrar and the chain itself. Now, in addition to the registrar, we need our big hack. So physical model with meta model properties. Gives me big hack. interfaces of the model to text transforms, and then this guy would just literally be a static well, something like static physical entities model pointer model. Something like this, right? This is a very, very big hack. So we just have a pointer here, some kind of pointer. It's static, and you will somehow supply it to us, and it has to be pointing. And we know it's not going to be dangling because it's going to be taken off a reference. Now, so that gives us the static state for the transform. And if we, for good measure, make sure we have, oh, there we are. Our LSB has done the job for us, just in the wrong place. Now then, where are we? So if we probably will need some kind of state. The state is a pointer. I wonder why we made it a pointer, but there must be a reason for it, so let's just copy it. So we need a shared pointer. Interestingly enough, it seems not very happy with the fact that we are calling this registrar. So that's perhaps why we bothered with the whole transforms, etc., etc., etc. So text transforms registrar. Right, something like this, right? Okay, now if I just look at this workflow, as you can see there's very few workflows now, which is really good. This means our refactoring is coming close to an end. Missed that one anyway. So let's have a look. This probably, as soon as you create the workflow, oh no, it uses a sort of a singleton style approach here, and everything is single thread in Dogen, so we don't have to worry about threading, so that's not a problem. So right, so now then what we need to then do is to say, let's just declare all this stuff. So this guy will just be this. We will also need all this nonsense. And just to make this compile, we'll just do exactly the same thing. And that's the same here. Make shared probably requires or should have an include. Okay, that should take us some way there. Now we need something similar for that guy, and then finally, oh, we need to implement our apply. Oh, we already are the registrar, so what are we missing? The model. Suspect just this, I think. Right, so now then, now what is this guy doing? So in theory, if everything we've done is gone according to plan, I should be able to go back to my assistant and say, please give me get helpers. And well, actually, before we even go to get helpers, let's just start with add helper methods, because I reckon this is the apply method in disguise. So start with that. Let's get a logger. I must say that I've been extremely lazy with my Emacs setup. We should really have shortcuts for all these things. It could be absolutely trivial to create a function that adds a logger, for example. Keep forgetting about these things. And then we end up doing this by hand all the time, costing us time. So here we are. So we have a logger. We need an element ID. I think that's going to be quite easy. So const auto ID e.name.id. Good spell. Something like this. Now, if the element dot helper properties is empty, no helpers are found. Otherwise, there are some. Now we do a get helpers here. Let's imagine that exists, and away we go. So as you can see, this was fairly trivial. However, one thing we did not do is we did not use the artifact. And also, oh yes, the reason why is because this apply method is not making any sense. Okay, so that's fine. Let's just say that we have a get helpers then. So get helpers will be something like this. So we have some kind of lists of the helper transforms, and that's just going to retrieve all the helpers. Now, again, I think we could just get away with a copy and paste job here. We're just moving code away from the assistant, so bit of luck. Oh, what up? Seems like we forgot that bit. Okay. And the helper transform is just us, so no point of having anything else. Right, so now then, how do we get the helpers? Well, we must have a registrar, right? So if I could just do something like const auto by reference helpers registrar dot the repository. Hopefully that find would now work. No. Wait up. I didn't mean helper repository, I meant helpers by family. Okay, so now I can simply say, please give me the helpers. If I couldn't find any as a problem, let's copy a few of these error messages because we're going to need them. Okay, and now finally, this will be whatever the errors are for transforms. Transformation error. Oh, PHP. Okay, so now then, where are we? And now we are down to the last few errors. Okay, so now we need to update the interfaces to match what they should have been in the first place. So we can't really have a get helpers like this. We need a get helpers that has an artifact, presumably. Maybe we don't need the full artifact, of course, but we are being lazy here. Just basically something that tells us where we are in the physical space, physical dimension. So if I just say something like const auto physical ID a dot name. Oh no, this has to be the meta name. ID. This is the physical meta ID. There we are. Should really not use the legacy names formatters, given that we don't really have formatters anymore. Okay, now then, so let's start by saying, please give us the artifact. Nope, let's start by saying, please give us the artifacts first. Hopefully that will retrieve us a list of helpers. Now, we won't be able to call isEnabled like this. Instead, isEnabled now becomes a much more complex incantation involving our hacked model. Let's just put the helper transform here. So isEnabled now requires a model, elements, an artifact, and the helper properties. Now, I'm not entirely sure this is all kind of lines up, but let's just say this is the first draft. And if we could dereference the model. Okay, and then the apply similarly will be slightly more complicated. So in order to apply we need a stream EA and the L properties. Okay, now then, so we've now implemented the classes that we set ourselves to implement. This course is not going to do very much just yet because this subset of classes that we try to isolate here, we try to isolate the functionality that we're having cycles with at the moment. But, of course, we don't have any helpers registering and we don't have any helpers implementing this interface. So the first thing we need to do now is to go through all the helpers and make them implement the helper transform. Once the helpers can implement the helper transform, we're now registering with the new registrar. In fact, to be honest, this is a bit annoying now because I don't think we can do this incrementally. We need to do 3 changes at the same time. We need to change the base class of helpers, or the interface they implement, which is this guy now. We then need to change the way eStreaming enable is implemented, taking the physical model, which is doable in the current infrastructure. Update all the context to point to this guy. Yeah, in fact, that is actually the best way to do. We don't really necessarily need to move to the new world altogether. So the first thing we're going to do is we're going to implement the helper transform, the new interface of helper transform across the board, and then we're going to start using eStreaming enabled the new world from the assistant. And then we're going to also register with the new chain. And then finally we can get the assistant to just call the new chain, supplying the parameters. And that should be sufficient for us to then start to move all the helpers, I think. And then we worry about the rest later. So okay, I think if this compiles, we've done enough for this video. Of course it won't compile. I think the problem will be the meta ID. It's not a problem. Let's just include Dogen.text, so actually the physical, if I'm honest, dot types perhaps, no, dot io, dot entities, dot physical. No, problem is we're in the wrong place. So identification, physical, meta ID. Okay, so I think we just need to make sure. Okay, more errors. Okay, we are also trying to stream the helper properties. That's fine. So let's just say include Dogen.logical. Again, IO. I think my brain is non-functioning today. Entities. Logical. No, helper. Properties IO. And we may have a few of these, so we just have to keep going until we get something that compiles. It's annoying that the LSP doesn't detect template-based errors. Not sure why, but it doesn't seem to be the case. Well, that's going. So we got an hour and 22 minutes, not too bad. Let's make sure we're not being called elsewhere. And that should work. So if all goes according to plan, we might as well start the commit. So let's just call this the first tab. Oh, actually, sorry, I made a mistake here. Don't really like to mix commits from different places, so let's call these text implement, so first tab, implementing helper chain related types. And here we just have some minor cosmetics. Text.cpp minor cosmetics related to names and include something that's not particularly important. And now because you're going to call it a day, well not a day but a morning, I guess. Might as well clock. Slowly but surely we're getting a little bit past the midpoint of the sprint. And that will be our morning, I should think. Push this across to all of our repos, and away we go. Alright, cool. So I think that was a productive morning. I mean, it was slow. No getting away from it. We should have done a bit more in this couple of hours, but we managed to get something done. And the idea really is to isolate these types here to get all the functionality needed to get these helpers moving, so that we can slowly but surely start pulling them out. All of these guys here, pulling them out from the current position over to their final resting place. So yeah, thanks very much for watching for the first part.